Hello everyone, my name is Mulutola Enoch and we are going to revise together CS 110 and number system or conversions of numbers in different given numbers. So the first question reads, convert 3b7 to a binary number. So we can start. So the value that you have been given, 3b7, this value that you are seeing there, it is in hexadecimal. Now they want us to convert this value to a binary number. So one thing that you should bear in mind is that the hexadecimal, so before we start answering, let me just explain a little bit. So hexa means 6 and then decimal means 10. So when you add, you find to say that you're going to get 16. So all hexadecimal are in base what? 16. Now these hexadecimal, they run from 0 to F. What does it mean? The range of numbers, they start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 9, the number that follows is 10, 11, 12, 13, 14, 15. Now in hexadecimal, what you should bear in mind is that numbers after 9, these numbers that you are seeing there, 10 up to 15, these numbers are represented by letters in the alphabetical order. So 10 is represented by A, and then 11 is represented by B, 12 by C, D by 13, 14 E, and then F, that is 15. So these are numbers that runs from 0 to F, meaning 0 to 15. Now they are telling us to convert in what? This same number that we have been given, that is in hexadecimal, to what? To a binary number. So one thing that you should do is that whenever you are converting hexadecimal to binary number, is that you are going to separate these numbers that you have been given, that is 3b7, like that. Now I'm going to rewrite 3. So B in hexadecimal is represented by that number, which is 11, and then 7, like that. So what I'm going to do now is that I'm going to put 4 numbers that when I add, I get 15. What does it mean? So if I put 8, 4, 2, 1, so when I add these numbers, 8 plus 4, that is 12, plus 3, that is 15. So these numbers that I have collected, I'm going to put these numbers on each of these given hexadecimals. So I'm also going to write 8, 4, 2, 1. Even this side, 8, 4, 2, 1, like that. Now the next question that you are going to ask yourself is that for me to get this 7 that is there must be certain number that I should add to get 7. So if I add 4 plus 2, that is 6, plus 1, 7. Now, where the numbers that you have selected there, you always replace them by what? By 1. So I'm going to put 1 there, also 1 there, also there, 1. And then since this 8 is left out, I'm going to replace it by what? By 0. So if you want, you can even draw the dotted line just to separate them so that you won't get confused at the end of the day. So we come to this part. I'm going to ask myself, what numbers can I add for me to obtain 11? So when I add 8 plus 2, that is 10 plus 1, 11. So the numbers that I've selected from that list, I'm going to replace them by 1. So 1, 1. 4 is left out, so it is going to be replaced by what? 0. 8 is picked, so that is 1. And then I go to this part, same procedure. So you are going to ask yourself, what two numbers or what numbers on this list that you can add to obtain 3? So you see 2 plus 1, that is 3. So the number that you have selected from there, you're going to replace them by 1. So 1, 1. 8 and 4, they are left out. So I'm going to put 0, 0. So these values that we have obtained, these values that you have collected, you are going to write them as your final answer. So what I'm going to do, I'll say, therefore, that hexadecimal that we are given in the question, so 3b 7 base 16 is represented by, you start now copying from this side going that side, that is 0, 0, 1, 1, and then there is this one, 1, 0, 1, 1, 0, 1, 1, 1. So there are 3 ones, 1, 2, 3, 1, 2, 3 in base what? In base 2. But most of the lecturers, they prefer you drop out these 2 0 because they'll change nothing. So you're going to simply say 1 1 1 0 1 1 0 1 1 1 in base what? In base 2. So this is the required answer on question 1. So we can proceed to the next question. The next question, they are saying we convert 1D29 to a binary number. So we can also answer that one. So we have been given our hexadecimal, that is 1D29. So same procedures. So they are saying we convert that hexadecimal in a binary number. So same procedures. So to avoid confusion or to make your answer wrong, but you know the procedure, the best way that just split them. So you are having there 1 D 2 and 9 there. So what you are going to do, the same procedure, assign certain numbers. So I said that D that you are seeing there in hexadecimal, it is represented by 13, as you can see there. So I'm going to rewrite first 1 13 2 9 like that, and then I should get 4 numbers that when I add I get 15. So that is 8 4 2 1. I draw a dotted line to prevent me from doing the wrong things. also, that is 8421. 8421. 8421, like that. So from there, what you're going to do now is to ask yourself, what number can I add from this list that I've written for me to get 1? It's just 1. So the number that I've selected from the list is going to be replaced by 1, and then the one that are not selected, I'm going to replace them with zeros. So 0 0 0, like that. And then I come to the second part. So I'm going to ask myself, what numbers can I select from this list that I've written there? So when you add 8 plus 4, that is 12, plus 1, that is what? 13. So the numbers that I've selected, I'm going to replace them by what? By 1. So 1 1. 2 is left out, is not selected, so I'm going to put 0 there. 1. All the same, even this side. So 2 is the number that I'm going to select. Why? Because when I add 2, I'm going to get 2 itself. That is 1 0 0 0. Also this side, what numbers can I add to get 9? That is 8 and 1. So 1 there, 1 there, 1 there also. And then the one that you have not selected, replace them with the zeros. Now from there, since you have finished writing, you're going to say, therefore, the hexadecimal that was given 1 D29 in binary number, it is represented by, so like I said, these zeros you can drop them because they'll change nothing. So I'm going to start from 1 1 1 0 1 0 0 1 0 1 0 0 1 in base 2. So these are the required solutions on question 1 and 2. We can proceed to the next question. So question 3, they are saying convert 1011 011 to hexadecimal. So we have been given the binary and then they want us to convert it to hexadecimal. So we have been given our binary number to be 10 1 1 0 1 1 1 as our binary number, and then they want us to convert that same binary number to hexadecimal. So what I'm going to do is this: hexadecimal, that is just the number that is in base what? Base 16. So now this is the binary number having the base 2. So I'm going to write 2 there, and then I'm going to ask myself to say, what number can I get or can I raise to this base which is in binary for me to obtain base 16? It's 4. So 2 to power 4, that is 16. Now that simply means that you are going to group these binary numbers that you have been given in 4 groups each. So let me do this. Let me rewrite that same binary number. So that is 10 1 1 0 1 1 1. So like I was saying, to say that since these 2 can be raised to power 4 to obtain base 16, which is the hexadecimal, that simply means that the 4 that you have put there, you are going to group these binary numbers in 4 group each. So That simply means that I'm going to start counting 1, 2, 3, 4. This is the group of 1. This is one group of 4. And then I'll also start counting 1, 2, 3, 4. So after doing that, what next? So what you're going to do is this. I'm going to put base 2 there, base 2 there, base 2 there, base 2 there. Let me just separate it like that. And then also this side, 2, 2, 2, 2. So the next thing that you are going to do is that now assign the powers on top of 2, so that starting from 0, and the power should keep on increasing. So it's going to be 0, 1, 2, 3. Also this part you start 0, 1, 2, 3. So that is 3. This is 2. Okay, so we proceed. So from there, what you're going to do is just to simplify these numbers. N number raised to power 0 is 1. Let me just do this. I separate them. And then 2 to power 1, that is what? 2. There you're getting. There you are getting. You are getting 4. There 8. And then here it's 8, 4, 2, 1. Now, if you observe very carefully, the time I was converting hexadecimal to binary numbers, I was using 8421. So that is where those numbers comes from. Now from there, what you are going to do is that you are going to start multiplying this number with the corresponding figure. So that simply means that I'm going to start multiplying. So I'll say 1 times 1, that is 1, plus 2 times 1, that is 2, plus 4 times 1, that is 4, plus 8 times 0, that is 0. I come to this side, 1 times what? 1 is 1, plus 2 times 1, you're going to obtain 2, plus 4 times 0, that is 0, plus 8 times 1, that is 8. So from there, just the issue of now summing up. So that is that plus that, 8 plus 2, 10, plus that, 11, 4 plus 2, 6, 7. So from there, you are going to now make sure you remember what I said. In hexadecimal, 10 is represented by what? By A. 11 by B. So that is B7. Base 16. So this is the final answer. So we can proceed to another question. So the next question, that is question 4, they are also telling us to convert that binary number to hexadecimal. So same procedure. So we have been given 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 0 as our binary number. Now they want us to convert it to what? To hexadecimal. So same procedure. So first step, what you're going to do is that you're going to separate them in 4 groups. That is, you're going to start counting 1, 2, 3, 4. This is one group. And then 1, 2, 3, 4. Another group of 4. 1, 2, 3. Now you can see that there are 3, but you can add a 0 because 0 won't change anything. So, and then you count to make them 4. So you just draw a dotted line just to separate them to avoid confusions. So from there, what you're going to do, write 2 everywhere. 2, 2, 2, 2, 2 there, 2 there, 2 there, also 2 there. Now from there, assign the what? The powers starting from 0 going up. That is 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. So from there, when you simplify that, that is 8, 4, 2, a number raised to power 0, it's 1. So 8, 4, 2, 1. 8, 4, 2, 1, like that. Now, the number that you have obtained should be multiplied with the binary number that you have been given. So that is 1 times 0, see? Let me do this. 8 times 1, that is 8, plus 4 times 0, that is 0, plus 2 times 1, that is 2, plus 1 times 0, you are getting 0. And then from there, that is 1 times 1, 1. So 8 times 1, that is 8, plus 4 times 1, that is 4, plus 2 times 0, it's 0, plus 1 times 1, it's 1. Also, you come to this side, that is 1. I'll start from this side. 8 times 0, that is 0, plus 4 times 1, that is 4, plus 2 times 0, that is 0, plus 1 times 1, 1. Now from there, just the issue of summing up the what? The number. So 4 plus 1, that is 5. So that is 8 plus 4, 12, plus 1, 13. And then 8 plus 2, that is 10. Now, in hexadecimals, when numbers goes beyond 9, they are represented by letters in the alphabetical order. So 5, I'm going to write 5 the way it is because it is below what? 10. And then 13. This 13 that you are seeing there, like I said to say, A is represented by 10, B is represented by 11, and then C is represented by 12. D by what? 13. So 10, 11, 12, 13. That is 13, meaning where there is 13, you are going to replace it with what? D. And then where there is 10, you put A. So this is your answer in what? Base 16. So we proceed to the next one. So they are saying the next question, convert 24E to decimal number. So we can also answer that one. So we have been given 24E. That is hexadecimal, and then they are telling us to convert it in decimal number. So each time whenever you are converting a number to a decimal number, one thing that you have to do, always look at the base that you are having, and this base is going to be multiplied by everything there inside. Always, whenever you are given any number and then they tell you to convert it to what? Decimal number. Look at the base. That base is going to be multiplied by everything inside the brackets. So what I'm going to do is that I'm going to start by 2. That is 2 multiplied by the base, which is 16, plus 4 multiplied by the base, that is 16, plus E multiplied by what? The base 16. Now after doing that, the second step is that assign the power on the base starting from 0. So that is 0, 1, 2. So that is 2 times, if I square that 16, I'm going to obtain, I'm going to get 256 plus 4 times 16 to power 1, that is 16, plus, so I'm going to ask myself to say, E in hexadecimal is represented by a certain number. What is that number? That number is 14 times a number raised to the power 1, that is power 0, that is 1. And then after you multiply, that is 250 something, answer times 2, that is 5, 12 plus 4 times 16, that is 64 plus 14. So it's just the summation of 64, 14 plus 5, 12. And I'm getting 590 as my base what? As my decimal number. So decimal number is in base 10, but usually they don't like showing that base. So that is the final answer. So this is equivalent to 24e base what? 16. So we can proceed to the next one. So the next number they are saying, the next question they are saying, convert 4b4.c8 to decimal number. So we have been given 4b4.c8 base 16. So like I said, whenever they give you any number converting it to decimal, one thing that you have to bear in mind is that look at the base. That base is going to be multiplied with everything inside the brackets. So I'm going to start 4 multiplied by 16 plus b multiplied by 16 plus 4 multiplied by 16. Even if there is a point there, just add. So that is c multiplied by 16 plus 8 multiplied by 16. Now, here you have to be very attentive. One thing that you should know is this. Here, after the point, I'm going to assign the base with the power 0. And then I start increasing that same power. So that is 4. Now the base, that is 16. So I'll start 0, 1, 2, going this side to the positive. Now after the point, these numbers, they are represented by negative. So that is negative 1, negative 1, negative what? 2. They making sense? So what you should bear in mind is that now from there you can now start simplifying. So 2 to power 16, that is 4 times 256 plus b in hexadecimal is represented by a certain number, and that number is 11 times 16 plus there, that is 4 times a number raised to power 0, it's 1 plus c is represented by 12 times. Now to kill this negative on power 16, what you have to do is to introduce 1 over 16 to power 1, close the brackets, plus 8 times, to kill that negative, 1 over 16 to power 2. And then from there what you're going to do is just the summation. First you simplify the numbers, times 256. So if you multiply there, that is 10 to 4 plus, that is 11 times 16. I'm getting 176 plus 4 there plus, so when I simplify that, that is 12 divide 16, which is 0.75 plus, that is 8 divide 256, which is 0.03125. So summation of everything there, 0.75 plus 4 plus 176 plus 10 to 4. So I'm getting 120.4.78125 as my decimal number in base 10. So that is the final answer. So that answer is equivalent to that one. We proceed to the next one. So they are saying convert 80 to octal number. So we can answer also that one. So we have been given A, D base 16, and then they are telling us to convert it in octal number. So octal number, what you should understand is that octal number is in base 8, but numbers runs from 0 to 7. That is for the octal numbers. So